Welcome to the new session of DTP application and internet technologies. In this session, I'm going to discuss about the internet technologies and the protocols. In earlier session, I have discussed about what is internet, the history of internet, about the intranet, extranet, and the comparison with internet, as well as the governance of the internet. So we all know that internet is basically a network over a network, and it is a medium for the communication between two end user. And why we called it as to end user, because both the users are physically the physically the actual location, right? Geographical locations are you can say the difference, the locations are different, but though it's a medium to communicate between those two people in terms of digital environment, we can say. So let's see. Internet is a worldwide global system for interconnected computer networks. Internet uses the standard internet protocol named as TCP IP. So for the communication purpose, it use the different protocols, right? But the internet use the TCP IP protocol. TCP stands for transaction control protocol, and IP is internet protocol. These two are the separate protocols which both work together for the communication purpose. Every computer in internet is by identified by the unique IP address. As we all know that we people are identified by our name, right? So if your computer use internet, so your computer name in terms of, we can say, IP address is unique. Each and every computer IP address is unique, right? They are not same, and through that IP address you can transfer your information from one computer to other computer. So let's see the example of IP address. IP address is a unique set of number. For example, 110.22.33.114. It's a example of the IP address which identifies the computer location. So in our normal life, in the traditional posting some letter or sending some information by the courier, right, we need the address, the location, right, where you want to post your letter. So it is like same for the computer. For posting, for transferring some information, you need the IP address. So a special computer, a DNS known as domain name server, is used to give the name to the IP address, because we can't remember this address, right? So the DNS server is used to give the name to the IP address so that user can locate a computer by its name. For example, DNS server will resolve a name like http colon slash double slash www.techteach.com. It's a we can say it's a URL, right? The name defined by, you can say, the DNS, the domain name server. It's a the domain name server of the particular computer. So that www.techteach.com to a particular IP address to uniquely identify the computer on which this website is hosted, right? So this website is hosted by the particular computer, and the files and everything is stored in that, you can say, that computer, and those information shared over the internet. So it's a unique address of that computer on which this website is hosted. The internet technology means the technology using one or more computer network that utilize TCP IP, IP or other architecture, or that uses a computer terminal servers, the routers, switching, hubs, many more things like multicasting technologies or other data processing or the transmission devices, in terms of like the regardless of the transmission speed experienced by the end user. So that may be possible through the cables, wire, wireless technology, set-top box or other technology, regardless of end users viewing device. So that is what the meaning of the internet technologies. So let's see in detail about the internet technologies and the protocol. Let's see how the internet technology works. So the next slide is about the OSI reference model. So OSI is acronym for Open System Interface. This model is developed by the International Organization of Standardization, and therefore also referred as ISO OSI model. The main idea of OSI is the process of communication between two end users in a telecommunication network can be divided into the layers. So you can see that in the figure that this communication model, the OSI model, consists of 7 different layers, with each layer adding its own set or the spatial related functions. Each communicating computer is equipped with the 7 layers of a function. So in a given message between user, there will be a follow of data through each layer at one end down through the layer in that other end. At the other end, when the message arrives, another flow of data up through the layer is receiving. So the same layers, the same model is following for sending the data, and the same model is following for the receiving of the data. So in the next slide we are going to learn in detail how this model is work. The different layers are there, so we are going to learn the each layer in detail. The actual programming and the hardware that furnishes these 7 layers of function is usually combination of the computer operating system. So the computer operating system along with the internet technologies, using this combination you can transfer your data from one location to other location, and that is for the communication purpose. So you can see the each layer has a specific function. However, the each layer provides a services to the layer above, right? So you can see that the different layers are like physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer, right? I have named all the layers in reverse order, right? Why? Because you will start with the physical layer, and physical layer works for the next work is for the data link layer. So again, the data link layer, uh, we can say, done the data link layer complete its job to start the work for the job for the network layer, right? So that is why we say that the each layer provides a service to the layer above, so it works for the above layer, right? So you can see your model with 7 different layer, and all the layer, I mean, the layer with the data. So how the data is going to be transmit over the communication channel through the, you can say, the internet service from one PC to other PC, or we can say from one location to other location. So it starts with like a bit, because your data understands only the binary data. So the set of bits, right? A 1 bit data, right? 2 bit data, we can say 8 bit data, 32 bits, right? 64 bits. So the first, the data in terms of bits, and then frames, and then packets, segments, and the data. So basically the data is going to be divided into the different packets. That is the that is the, we can say, the the functionality of the internet, right? The internet follow the packet switching method. So your data is divides into the small tiny packets, right? So the whole data, let's say, divides into the multiple packets, and all the packets are transferring from one end to other end, right? And on by receiving on other end, again all the data collects together, and again it forms one, you can say, the common later, or we can say the information. So first, the data is divides into the packets, transferred to other computer, receiver receives all the packets, and again all the packets club together and got the information. So the reason behind this, like the large data, you if you divides into the small packets, so the communication becomes a faster, because a less number of data moves faster than the large number of data. So that is the reason to divide your data into the small packets, we can say, right? And transform over the network and received by the receiver. So that is how your data moving from one end to other end. Let's see how it works, how the actual OSI model works. So let us start with the physical layer. Let's see, the physical layer is responsible for activating, maintaining, and deactivating the physical connections, the physical connection for the communication, we can say. It defining the voltage and the data rates needed for the transmission. It converting the digital bits into the electrical signals, deciding whether the communication is simplex, half duplex, or the full duplex. It's a communication channel, right? That you want to, I mean, that that channel, that data transforming through the simplex, the half duplex, or the full duplex transmission, right? So converting the digital bits into the electrical signals, because as we know, the data, I mean, whatever we write, we know that that we are typing the English language, but computer doesn't know English language. So our medium of language is different, the computer medium of language is different, because computer understands the binary language, and we can say human understand the English language, so the language, the language, we can say the platforms are different, so there is a conversion of the language first, right? So same way, if two computers are there, so maybe the platforms are different, so for that also you need a data conversion, right? The one computer understands the data in other in other way, and in other computer, right? That depends on the platforms and the applications and all. Fine. So the you will require the conversation. So that is about the physical layer. Then it comes data link layer. The data link layer performs for the synchronization and error control for the information which is to be transmitted over the physical link. It enables the error detection and adds the error detection bits to the data which are to be transmitted. So it performs the synchronization, right? And the error control for any informations. It is a responsible for the responsibility of the data link layer that no error comes for the between the communication, right? During the communication, we can say. So while transferring the data, there should not be the error. That is the, we can say, job of the data link layer. So if certain error comes, so that is detected by the data link layer, we can say. The next, that is the network layer. So to route the signal through the different channels to the other end, so how you are going to connect two computers, so is decided by the network layer, right? How you design, how you define the channel, right, between two computers, because at the end you want to send the information from one computer to other computer. So the communication channel, right, the network is that signal, the channel is implemented, or the design through this network layer, we can say. So it routes, it directs your data, right? It gives the guidance that how you have to move and where to move, you can say. To act as a network controller by deciding which route data should take, to divide the outgoing message into the packets and assemble incoming packets into the message for the higher level. As I have told earlier, that your messages divides into the, your information divides into the packets, and it transfer over the network and received by the receiver. So at the end of the receiver, again you need to it requires to assemble all the packets and define the common, you can say, the one message, whatever the message is sent through the sender. So data divides into the packets, and on other hand assembly of all the packets and transform into the message, right? So done through the, that is done through the network layer. The next is the transport layer. It decides if the data transmission should take place on parallel path or the single path. If multiple packets are there, so you want to send your data on the multiple path at same time, or on the single path, one by one packet you want to send. So that is the responsibility of the transport layer. It performs multiplexing, splitting of the data, right? So transport layer is responsible for that. It breaks the data group into the smaller units so that they are handled more efficiently by a network layer, right? So your data is going to be divided into the different segments. See, the transport layer the packets into the different segments. The session layer uh, is responsible for manages the messages and synchronize the conversation between two different applications. It controls the login on and off, the user identification and the session management, because it is like you are posting your data, you are sending your data, but there should be a assurance that the message is going to be received by the right receiver, right? So the identification of the user, identification of the receiver is very important. And to log in up, I mean to create the session for the communication is also responsibility of the session layer, we can say. So it's a you can say the authentication is provided by the session layer, the authentication of the user, right? The next is the presentation layer. This layer makes it sure that the information is delivered in such a form that receiving system will understand and use it. So that is what the presentation layer. Application layer, it provides the different services such as the manipulation of the information in several ways, the retransferring of the files of the information, distributing the result, etc. The functions such as login or password checking are also performed by the application layer. If your data is secured, right, so sometimes you need the encryption of the data, and at the receiver end you need the decryption of the data. So it is like encryption of the data is like if you write your letter, your information in the English language, while you encrypt your information, so that transform into some symbolic language so that nobody can steal your information or nobody can read your message. Only the receiver having the password to decrypt the message, right? So that is the responsibility of the application layer. The next that we have the different protocol along with the OSI model. I mean for each layer will require a few separate protocols, right, for the better communication, I mean the secure communication as well, we can say. So the TCP Ip is one of the protocol that is used by the internet services for the communication. Let's see in the detail what is TCP Ip. We have the set of protocols like TCP Ip, SMTP, SNMP, POP protocol, right? The different protocols are there. Let's see one by one in detail. So TCP Ip are two separate computer protocols. The IP is a part of that obtains the address to which data is sent. The TCP is responsible for the data delivery once that the IP address has been found. I hope you people are clear with the addressing, the IP address of the computer, which is I have discussed before 3 to 4 slides back. So the IP is the part of obtaining the address, right? The transmission control protocol. The transmission control protocol is the communication standard that enables the application programs and computing device to exchange the messages over a network. It is a design to send packets across the internet and ensure the successful delivery of the data and the messages over the network. So that's it for today's session. in the next session I'll be discuss again. I'll start with the TCP IP protocol. I hope you people are getting the OSI model. uh, I mean, you people are understand the OSI model very well, and the responsibility of each layer of the OSI model is also important. So I hope you people are getting the concept. Thanks for watching my video. We'll meet soon in the next session with the different protocols.